All right, how do I make this big? Isn't there like a blowout function? Let's see. Here it is. There we go. So for the first one, the little with the alpha and the omega, so alpha cosine WT, beta sine WT, find T of T and N of T. You guys didn't have to do these two parts. These went on your quiz. So that wasn't there. That wasn't there. Okay. So anyway, you only had to find these at T equals 0. So if you find T of T, remember T of T is R prime over the magnitude of R prime. So there's your T of T. Plug in a 0. Sine of 0 is 0. Cosine of 0 is 1. So you get B over, or beta, over the square root of 0 plus beta squared, which is beta. So you end up with the vector 0, 1. And then, let's see. And then you wanted N of T. I don't show my N of T, but that's okay. So N of T, remember, since it's a vector in just 2 dimensions, you could just flip and make one of the sides negative. The only side to make negative is the 1. So it's pretty straightforward. Yes. Good question. So I was just thinking that when I was looking at this, thinking the square root of b squared really should be absolute value of b, not just b. Do we know that beta? I don't think we know anything about beta. So really, technically, this should be beta over absolute value of beta. Not square root, not plus or minus. There's no plus or minus because it's a square root. Square root is positive. So, okay. Oh, Sophie's giving me the big eyes. All right, let's see. So the difference between x squared equals 4, where x is plus or minus root 4, which is plus or minus 2, right? And x equals root 4, which is just 2. Square root is naturally positive. Yeah. You don't ever put your own plus or minus if you're handed a square root. It just is what it is. Okay. So the only thing that concerns me about this, though, is when you do the square root of b squared, if b is negative, it makes the square root makes it positive. So technically, I should have an absolute value around the b. Yes?
So for the b for normal vector, why can't it be like 1, 0? Isn't it so normal to the tangent vector?
Yeah.
So could it be
Although technically, if we're talking about N of T isn't just a normal vector, it's the principal unit normal vector. And the principal unit normal vector has to be in the direction of the curve, not just any vector normal to the tangent. So I think it's the negative 1, 0 that makes it be normal in the direction of the curve. All right. Okay. So that is that. But if you wanted to keep it with b's, like I was totally fine if you accepted it if you kept it in terms of b and didn't put in 1. Okay. So number 2, just tell me if there's any questions on number 2. You just antiderivatives with unknown constants, plugging in the numbers and solving for the unknown constants. Questions? Any questions? Happy to work it through. Okay. Smoothness. Smoothness. Any questions on smoothness? You know what I found? Smoothness was not in your homework at all. Yeah. So no, it's still on your test. But yeah, I don't know why your book doesn't have smooth. The book has smooth. I'm 99% positive that the book talks about smooth, but for some reason they didn't put it in any of the homework problems. I went back through the problems for that section and couldn't find a single one that talked about smooth. Yes, Jack?
Just to confirm, so smooth is where the curve is both continuous and where the derivative is not equal to 0, 0, 0.
Or undefined. So if your derivative is undefined, the curve is not smooth at any point, any value of t. Or if the derivative is 0, 0, 0, all at the same value of t, then the curve is not smooth.
But like for the continuous, it's the regular curve, not the derivative.
Yeah, if the original curve is discontinuous, then the derivative is going to be undefined anyway. So if you just look at your derivative, you're pretty safe. Okay. Rishi, do you have a question? Okay. Just stretching. All right. Okay. Good. Any other questions about smooth? You all got it. I mean, I can't think of anyone that didn't get it. So, all right. Okay. All right. Projectile motion. You say, "Oh God," like it was just so terrible, but you did okay. Well, I mean, unless you didn't. But yeah. So for the most part, it was good.
My number was so high that I spent like a lot of time trying to think of it.
Yes.
I couldn't find where I messed up.
I was actually surprised that nobody in here asked me how many feet were in a mile. You all seem to know it. Oh, I gave it to you?
Yeah.
Oh, that's why you guys didn't ask me. Oh, I didn't have it on my answer sheet, but I gave it to you. I forgot. I must have added that after the last time I gave this quiz when somebody was asking me. Yes.
Yeah, I didn't even use that note for a quiz.
Really?
Are we going to have to know any conversions for the test?
You should know there's 3 feet in a yard.
I covered it.
Okay. 12 inches per foot. Okay. All right. Okay. So Tejesh, was it only the units that kind of messed you up, or do you want me to show you how to work it out? Just the units. Okay, good. Any other questions on the baseball player problem? Okay, so for the next one, you guys had to find a set of parametric equations for the line tangent to the space curve. So in order to find a line tangent to a curve at a point, you just need a point and a direction vector, right? How do you find the direction vector? It's the derivative of your vector valued function. So you have your derivative, r prime, you plug in. Now, here's your point. You need a t. This one's pretty easy. If your x is t and your x is 1, then your t is 1, right? Same thing for y in this case, right? So it's usually pretty simple to figure out what the point is or what the t value is based on the point. Then you plug in that t, that's your direction vector. I almost said slope, but that's your direction vector. And then it's just your standard equation of a line, direction vector times t plus point, direction vector times t plus point, right? Any questions on the equation of the line? Okay. Arc length. How are we on arc length? Any questions on arc length? Not much.
I have a question.
Yes, Tejesh.
So if you were to like anti-derivative like cosine t plus p sine t, you'd use the like tab method, right?
Yes, for t sine t, absolutely. That is a tab method. Yep. But did you have to do that? No,
I
right?
did it, and then I realized I didn't have to do it, but then I wasted like a lot of time trying to figure out how to anti-derivative that.
Yeah. Well, it's been a couple of years for you. Yeah. So t sine t is a tab method, but you didn't have to do it because if you did your math right, you ended up with a cosine squared plus sine squared that could go to 1. Yes, Anna?
Would you recommend studying the tab method in integration of parts?
Not for this, no. Okay. All right, curvature. So I gave you the formula for curvature. There's a couple different versions. Over time, I have learned that the type that I like the best is the r prime cross r double prime over r prime cubed. But you could use either one of those if you want to do t of t over r prime or t prime of t over r prime of t. You could do that, but I like the cross product one. So Just about everybody got this one, so it was fine. All right, any questions on curvature? Okay. Do you all understand radius of curvature? You find the curvature and then you just flip it. Radius of curvature is another topic that was not in your homework. Again, this book just doesn't emphasize it. But it's not hard. You just find the curvature and you take the reciprocal. All right. So, any questions on radius of curvature? We're comfortable with curvature? Okay. All right. What about velocity, speed, acceleration? Any questions? Anyone want to see it worked out? Do y'all remember the derivative of tangent? I think there was only 1 or 2 quizzes where people didn't remember the derivative of tangent. So, yes, to Josh. You'll have to know all your derivatives. Although, to be honest, I don't ask you any inverse trig on this test. So there you go. 6 less things to memorize. Yes. So the test is, the first part is calculator. So the first part is where you're going to find like your projectile motion and stuff. So I have you take the first part with a calculator, turn it in, and then I give you the second part, and you just put your calculator away. So the first part isn't very long, but it's basically just like the process. Okay. All right. Okay. How about finding points where the curvature is 0? More curvature, a lot of curvature. So I took off a lot of people's quizzes just out of pickiness because I put the word points and a lot of you guys just gave me X values. So that was just me being picky. There's a problem on your test where I asked for points, and just today, this afternoon, I was looking over your test, and out of mercy, I decided to put points in bold letters. So I bolded the word points on the one on your test when I asked for points. Any questions? I'm happy to work problems out. Amal, I swear, this really isn't even worth publishing, but I will publish it for you, but they're really not asking me much. Yes, Laura?
So, we get these formulas, right?
Yeah. Oh, so Laura asked, will you get the formulas on your test? Yes. And I saw the Normandale test today. So, here, I'm going to pause so I don't start publishing me talking about the Normandale test.